We want to sketch the graph of a function that is continuous on the interval 1, 5 and has an absolute maximum at 4, an absolute minimum at 5, local maximum at 2, and a local minimum at 3. So we have a sketchy graph with those properties. Let's see. The absolute maximum occurs at 4. First of all, we see that the graph is a continuous function. There is only one piece with no jump or discontinuities. So it's a continuous function and it's defined on the interval 1, 5. Then we have an absolute maximum at 4. We can see that this value here is the highest point on the whole domain of the function, the whole graph. So that's the absolute maximum. In this case, it's also a local maximum. We have a local maximum, an absolute minimum at 5, and we see here that the lowest point in the graph and the whole domain is this value here at 5. So here we have an absolute minimum. And then we have an absolute, a local minimum at 3 also. Local minimum 3 we have, or the only, in this case, the only local minimum. Because if we see close to value 3, we know that the image of that point of 3 is the smallest value of the graph around this value 3. But it's not the lowest value of the whole graph, because the lowest value of the absolute minimum is attained at 5. But this is a local minimum at 3. This part here. Now we have a local maximum at 2. So at 2 we have a local maximum here. Because if we look around 2, very near the value 2, we have that the highest point or value in the graph corresponds to the image at 2. So here we have a local maximum, and here we have a local minimum. And that's it. We don't have any requirement at 1. The important thing is that at 1 we have an image that is not that is neither the absolute minimum nor the absolute maximum, in order that the string values are attained at 4 and 5. And that's an example of the function fulfilling these 4 properties here. We can remark that at 2 we have an absolute maximum, but also a local maximum. And that's it.